Hi there, back again with a short review of my RTB2004. I thought this time I'd take a look at the maths functions on the scope as I've been using them recently. I've been doing some work with a switch mode power supply and also with a diode rectifier that I was building, and I wanted to take a look at the signals coming out of that. And I don't have a differential probe, so I was actually using the maths functions to make a sort of poor man's differential probe. But what I have been is extremely impressed with the maths functions on this scope. Although it only has the basic plus minus multiplication and division functions at the moment, I'm rather hoping that in one of the upgrades to the firmware there is talk that they might give additional maths functions, as does the 3000 series scope, which already has that. But what I thought I'd do is take a look at this setup that I've got here. First of all, I'm using a signal from the actual scope coming out of the signal generator and feeding that into a bridge rectifier, which I'll set up, and we'll have a quick look at how I've set that up. Right, we're looking at the breadboard here, and I've got set up some 1N5399 rectifier diodes set up as a bridge rectifier, and I'm feeding from the signal generator of the RTB2004 a 5 volts sine wave peak to peak just at 50 Hertz, and then what I'm doing is on channels 1 and 2 I'm taking the output of the bridge rectifier, and on channel 3 I'm actually looking, or will be looking when we look at the screen in a minute, at the input signal, which is just the sine wave. What I've also got is a 20 k ohm resistor over to the right, which is over here, which is just the acting as a load, just so that we've got a very small load of a few milliamps effectively coming out of that, so that we can see the signals. What we'll do now is I'll set up and have a look at the screen so that we can see how those signals are shown in the maths functions. Right, returning now to the screen, we should be able to see on the screen on the top the maths waveform. Underneath I have 3 waveforms all lined up. The orange one, which is actually channel 3, which is more sort of red actually on the screen because I've set it up as temperature at the moment, I think. Oh, sorry, no, it's not set up as temperature, sorry. The channels 1 and 2 are, I'll explain in a minute what I've done. But channel 3 is the 5 volt waveform. So if I switch off, I think I can do this. If I switch off channel, yeah, I can. If I switch off channel 1, I have to leave one of the channels on for the maths waveform to work, which actually is a little annoying because on the Keysight I can actually set up and then switch my analog channels, which I'm doing the maths on, completely off. But on this, if you switch both off, you seem to lose it, which seems a little bit odd, and it's just a shame they've written that. Maybe they'll look at doing that as a firmware update, because if I switch off channel 2, for instance, I've set everything up and this is the maths waveform at the top. If I switch off channel 2 by going to off there, you now see that we've still got channel 3, which is the actual waveform, which is a 50 Hertz 5 volt peak to peak signal, which is coming in on probe number 3. But I've lost my maths waveform, which was on the top of the screen there. If I want to get that back, I can switch on one of my channels. No, sorry, I think it's got to be channel 2 actually for some reason. Just see if I can switch off. I don't know why. It has to be the second channel. It's really strange. Yeah, if I switch on my second channel, now my maths actual waveform is here, and it's at the bottom here where I've got the cursor, and it's C1 minus C2. So if I switch C2 on, I can actually see it. If I switch off channel 3 now, which is just the waveform on its own before it goes into the rectifier, I should have explained that, that's before it goes into, that's gone now. So this is now one output side of the bridge rectifier using the probes as a poor man's differential probe, so I've got no negative being touched anywhere. I'm only reading on the tip of the probe, and that's one section of the waveform. If I switch on my other section, which is channel 1, you can see the top end. Then I've set up the maths waveform. If I go to the maths menu, go to menu, you'll see here mathematics, source C1, which is channel 1 minus C2, and I can switch that on and off. If I switch that off, this waveform disappears at the top of the screen. If I switch it on, my waveform comes back. What I can also do is I can position my maths waveform using that to go up and down, and also I can scale the maths waveform. What is strange, and again it just needs to have some alteration because I can't find a way of doing it, is that this doesn't give you a fine adjustment. Unlike the analog channels and on my keysight I can push to get a fine. If I want to get an actual another figure, if I click on the box, I adjust it, then I click on the box, then I can actually set up. So this is at 500 millivolts. If I want to put that, say, to 400 millivolts, I do 400 small m, and that waveform went up in size because each one is now worth 400 millivolts instead of 5. But I can only enter it by, I can't find any way of entering it other than by touching that, bringing up my vertical scale for my maths, clicking on it with the mouse or touching it, and then I can enter it. There's nowhere in the maths menu, which is really strange, to actually just enter it. So if you go to there, you can't just click on it to bring it up, which sometimes you can. You can only go to menu or auto scale. Auto scale, it sort of brings up the whole screen. I can adjust that by doing that. I can bring my maths up by holding on the left side there and just dragging the label. So I've got my maths there. But if I want to adjust it finely, I can either adjust it using the scale knob, but there's no push to fine, so I pushed it and it's still the same, whereas normally on the other channels you can push to fine and fine adjust, but you can't tweak it like that, which is a shame. So the only way I've done that, I've discovered a little trick at the moment, is do that, bring it up, click on it or touch it, then enter. So if I want now, say, 390 millivolts per division M, and there my 390 millivolts, I can still adjust it here, or I can, which I can also position, click on it and alter my division. So I'm 400 millivolt divisions above my center of the screen. If I want to make that, say, 425 millivolts, this should, I clicked it too quickly, it would have moved up slightly from that was my offset from the center of the screen. So that's my maths channel there. If I want to bring in my channel 3, I'll switch that on here, and I've got channel 3. Now channel 3 now I'm actually showing as a waveform that's color wise. I'm adjusting that with my mouse, default, but if I want to bring that up and just put it on to, say, another color, temperature, fire is actually better because I can see it a bit clearer. The other thing I have noticed with this scope, which I really like, is that unlike my keysight, the maths channel has the same controls for brightness and for persistence as the other analog channels. So if I alter, which it doesn't on a keysight, if I push my button to alter my brightness and then I say alter my waveform intensity here, I can actually use my mouse to bring my waveform intensity down now. So I'm using my mouse wheel. You'll see that not only am I adjusting, so that's 20%, not only am I adjusting my signals here on my analog channel, it's also adjusting the maths waveform, which on the keysight, and I don't know on other scopes, I can't remember on my Rigol, I don't believe you can. So this treats the maths waveform display exactly the same as any of the analog channels, and I can just do that with my whiz wheel on my mouse, which I can do at any time, and it's also altering the maths one, which I really like actually. I've got my grid set quite high here. I'm just going to set my grid a little bit lower. Normally I don't like to have the grid so strong. Obviously you can change the grid, so if that grid is annoying you, you can change it. You've got options of how strong the grid is there by the percentage, and I'm using the mouse wheel, so I'm bringing that right up to 100. I can put my grid back down again. I can also go to grid here and bring up other options, so I can bring lines, I can just bring the center reticule, which I quite like with dots, or I can switch it off completely. And you can also, of course, you've got your annotations. If I put my lines back on, we've now got the millivolts and the timing in milliseconds. You can switch your annotations off, but I like to leave my annotations on all the time. I can also track to grid, which basically locks the waveform to the grid, so that if I move my waveform, might not be easy to see if I move my waveform on this. Yeah, that's easier. I'm moving my grid with, so as my waveform is moving, it's moving the grid as well. If I want the grid, bring that back to center by clicking, if I want that not to happen, I can go to there, bring up, go back, go to grid. I can actually take my track grid off, Now when I alter that, you'll see my waveform moves, but it's not moving my actual grid. The grid locking to the waveform is probably more useful for serial and I2C and decodes like that, where you want to lock a specific bit rate to the width of the cells on the screen, but it still can be handy sometimes to do that. What you can also do on this, of course, is you can also bring up your cursors and use your cursors to measure this waveform, which I will show. I'll do a brief demonstration of that now. Right, looking at my cursors now, if I bring up my menu, clicking on that, and I bring up my cursors, which I think are at the top of the screen. Cursors. Sorry, it's there. Normally use the button. It's easier with the video just to use the menu. I've got here my type of cursors. I've got vertical cursors, horizontal cursors, vertical and horizontal, so they track along a waveform, or V markers, which tracks along a waveform. I think vertical and horizontal bring up both 4 cursors at the same time. V marker tracks along the waveform, which is quite nice. Let me just show you that actually. If I'm on maths, so my source here, I can either select C1 and my little tracking has moved to the channel 1, so it's disappeared, C2 and it's gone on to C2, C3 and it's gone on to channel 3. If I click on maths, I'm now on that. So now I'm tracking. You can also set your cursors to couple together and also to track the scaling, which is something else which I'll show you, which is actually very useful. Set to trace means that it clicks onto the trace, and set to screen means if you've put them outside the screen you can bring them back in if you've altered your time base and you're not tracking the scaling. So now if I use my button here, my analysis button, you can see that I'm actually, that's moving that little crosshair on number cursor 1. So this one here is cursor 1, this line here, and that's moving. If I click on that now, it will now bring me highlight cursor 2. I can now track the waveform, and the crosshair basically stays on the waveform. So if I want one cycle of the wave, if I do that, I can now see my delta time between the 2 peaks and probably the frequency as well. So my delta time is 9.861 milliseconds. It also gives me my delta V, my difference in millivolts between the 2 cursors, etc. So if I wanted to see what my difference was between, say, 1 and 2 there, so if I put my cursor number 2 there, I'm now actually a delta V of 1.5 volts, 1.505. It's altering a bit down here. So you've got all your cursor readings here. I think you can also drag these by using the mouse, and you can also of course drag them on the screen as a normal cursor. So I can drag that to there, and I can drag that to there. These again are quite nice because with this screen protector you get a little more friction on the screen, and I think it's easier to control them. If I go back into my cursor menu, I can actually push my cursor button as well, which is down here. Sorry, pushed it twice. That's it. If I now go to normal cursor, so if I go to vertical, I can do that. Actually, let's do horizontal, it'll be easier for what I wanted to show. Horizontal, click on that to get rid of the menu. I can now alter my cursor, so that's my cursor 1, you can see at the bottom of the waveform. If I now click on that, I'll go to cursor 2, I'm altering that, and because this button is indented, which some people don't like, but I actually like the indent, you can adjust it incredibly finely. So I'm sitting right on the top of the waveform there, top and bottom, and again my delta V is 1.5402. My V1 is minus 36 millivolts, so I'm sitting just under the 0 line, and my V2 is at 1.504, so my delta V is 1.5402, which is the difference between these two figures here. I think I can also position my cursor. If you click on a cursor, and let's click on that cursor, I'm sure I can do it. So now I've got to click on it here, that's how I do it. If I click on V2 here, I bring up this Y2 position. If I wanted to put my cursor at say 1.3 volts to say where that was on a particular waveform, I'd put 1.3, I'd click enter, and now my cursor's actually gone to 1.3. If I want to put my bottom cursor, so my V1, click on V1, brings up my menu. I can actually type in, if I want that at say 500 millivolts, I just go 500 millivolts, and that line now has set itself at 500 millivolts. And if you of course had cursors that were vertical, you could also set your time base from your trigger position, so that's quite useful as well. If we go to cursor, we go to vertical, say we're now in vertical position. I think this times from your trigger position, so if I now time that and I say I want 5 milliseconds, that cursor has jumped 5 milliseconds from my trigger position, which is there. And you can do the same with a cursor 2, and of course you've also got all your timings and your deltas at the bottom for your cursors, and those cursors can be applied to the maths waveform as well as any of the other channels. And I think also it can be applied if you've created a reference waveform, which I'll do in another video because it's too long to do now. But if you created a reference waveform from this, you'd also have the option, it would pull up here as a reference waveform, because this alters dependent what's on. So if, for instance, just to show you that, if I switch my maths function off by going mathematics off, if I now go to cursors, when I go to source, my M has disappeared because it knows that I don't have my maths channel switched on, as I also don't have channel 4 on, so it doesn't give me that source. So my source will alter. If I now switch my maths channel on, so my maths comes straight on, if I now go to cursors again, you'll see that that will have a menu position for maths. So this menu alters relative to the displayed channels, and obviously you can't select a channel that's not actually on, because obviously that wouldn't be possible. Okay, so that's it. Set to trace will actually put the cursors onto the trace and lock them onto a position on the trace. That's vertical. If I go horizontal and I put set to trace, it should actually oh, sorry, I'm on C1, that's why I put it on maths, sorry. That's it. Now if I so I'm on maths horizontal, if I set to trace, yeah, my cursors have actually automatically gone to 1 and 2 there, have actually set to my trace there. If I go, so it's got my peak to peak effectively. If I actually put it onto a vertical position and now go set to trace, my cursors will jump onto a position on this, which should actually give me one cycle of the waveform normally, if it can work it out. If I've got my cursors outside the screen, so if for instance I've put my cursors, if I move my cursor number 2 outside the screen and it's got 2 with an arrow, if I move 1 outside the screen, quite useful, or you've altered the time base, you can now go cursor and you can now set to screen, and it will bring your cursors back into the screen position again without you having to alter the time base. The other thing that this does, if I alter the time base, my cursors are moving with my time base because I think I've got them set to that. Yes, I have. If I go to track scaling and switch it off, if I now alter my divisions, you'll see my cursors are staying in the same position on the screen. So it's quite useful. So now that has no purpose, I've altered my time base, but you can see that the cursors are not staying in the same position. If I go back and I put my cursor so they're there and there, at 1 and 2 there. If I now go cursor, and it's quite a useful function I use most of the time actually, if I track scaling, if I now alter my time base, you'll see that my actual cursor has stayed on the same position on the waveform, and if I now go the time base the other way, this will come over with it. So as I move it, it's moved over and it's kept in the same position on the waveform, which is quite useful actually on that. Okay, so that's the cursors. We'll have a look at the function generator next, just to explain how I've set that up for this and some of the functions on it, because it's actually got quite a powerful function generator on this scope, so we'll have a look at that next. Right, let's look at the function generator now. If I put my function generator on by selecting generator, obviously we've got the choice of sine, sync, rectangle, pulse, triangle, sorry. ramp, arbitrary, exponential. Arbitrary, you can actually load, and you go to arbitrary setup, you can load a waveform. So if you've had one already saved, if I load up, say, that waveform which I stored the other day, you can actually bring in your own waveform and create a waveform from something that you bring in. But let's go back to sine, which is what we're using here. We've got frequency for the standard frequency input, and I've got 50 Hertz here. If I want to change that, I can click on it, enter my direct frequency. So if I want 120, and I go enter, my frequency is now changed to 120 Hertz. If it's just triggering very slightly, just bring that trigger up a bit. I can also use this button to alter my frequency, and that's speed sensitive, so if I flick it, it will go up much quicker, and if I do a small amount, it will go just by a small amount in quite fine increments. If I want to set that back again, I can touch it, I can enter 50, enter, and I'm back to 50 Hertz again. Amplitude is peak to peak voltage, and again I can use the button here to adjust it in small steps. In here I'm doing actually in 10 millivolt steps, and I go back up to 5 volts. I can adjust my offset, I can adjust my noise. Now I got confused actually about a week ago. I was trying to set noise and I thought there was a bug in the firmware because I'd set something to the 5 volts peak to peak, and I tried to dial noise in and it comes up but it's not moving, and I can't actually, when I click on it, I was getting minimum 0, maximum, which this doesn't make actually much sense. They've obviously got a bug here, but if I try and enter 5% and enter, it doesn't do anything, and I discovered after a while that it's because it's at the peak. Let's get rid of that, sorry. I discovered after a while it was because it was at the peak. So for instance, if you go to say 4 volts peak to peak, now I'll be able to enter noise, and if I dial my noise, I can go up to 40% noise there. If I now put in 4.5 volts peak to peak, I won't be able to have 40% noise. It'll actually go down to 20, because 20% is the maximum you can put in at 4.5 volts. So, but the noise is quite useful to be able to dial in any amount of noise. It's just subject to the fact that once you're at the maximum of your voltage peak to peak, you can't put noise on. You've got sweep, so you can set a sweep up. So for instance, if I want to set a sweep up, say from 20 Hertz, that's 19.99, to 80 Hertz, I want my sweep to take say 4 seconds, and I want it to be a linear sweep, not logarithmic. If I now put that on, I'm now click rid of that, and you can now see that it's actually sweeping my signal for me between those. It's a shame it goes from the number from to and then go straight back the from again. It doesn't go the opposite way, and there's no way of adjusting that. It's just a shame that you can't have this set on the sweep. It's quite a powerful feature actually, but it's just a shame, which the Keysight doesn't have sweep at all. It's just a shame that this can't be set to go from start to stop and then back from stop to start, effectively going, you know, one way and then back down again. It goes all the way, stops, and then goes back to the beginning again. But it's still a useful thing to be able to sweep frequencies for components. Say if you wanted to sweep something with a set frequency to test a frequency response of a component, you could set up your frequency sweep, and obviously you can set this up to whatever you want. So I can go from 1 Hertz to 25 megahertz, because the sine wave will go up to 25 meg, so you can set your frequency up, and your sweep time maximum I think is 10 seconds. I don't think it makes any odds whatever you set that to, so I think if you set that to 1 Hertz and you set your other end up to say 25, I know that's gone crazy because we're not got our time base right, but I don't think my sweep time alters. No, it's still 10 seconds maximum, which is a shame. But anyway, let's take that back off. So that's switched off, so I'm back to my 50 Hertz wave. Modulation, you've got standard AM, FM, ASK and FSK frequency modulation. You've also got depth settings here, and you've also got AM depth as well, so you can adjust your amplitude modulation. So when you switch that on, that's now amplitude modulating that at 1 megahertz. So let's put that at, say, 200 hertz. I don't know what that will look like. Yeah, looks a bit odd, but and you can alter your AM depth again. But obviously these settings are just arbitrary. I haven't put anything in that makes any sense, but I'll switch that off. Okay, so that's back out of there. You can invert your signal, so if I do that, it'll invert my signal, which is not making any odds at the moment. Not quite sure why. Maybe I just wouldn't. Oh, I wouldn't particularly see it actually. Yeah, you can see it on here actually. Your math waveform is going to stay the same, but I think if I switch off my channel, oh, you won't see it. Sorry, of course you won't see it because it's a sine wave, so you won't see any difference. If we put this to a pulse, we should see it. If we put that to a pulse and then I invert my signal, yeah, the pulse has gone the other way. You can see the pattern of the pulse there. It's a bit difficult because the other waves are there and it's going through the rectifier still, but if I then uninvert it, you can see my pulse, my top of my pulse on my red waveform is there. If I invert, my pulse has gone the other way, so my waveform is there, so you can see that altering. It's quite a powerful function generator and very accurate. I actually was measuring the frequency of this, so I've got a TTI frequency counter, TTI frequency counter that I've just had set up properly, so I've just had it calibrated, and that showed that this frequency generator was giving out signals very, very close to the frequency that it states. Obviously, because there's only a certain number of decimal places you can enter, so for instance, if I go to sine wave and I want to enter a frequency of 3.2345678 so that would be megahertz, say. When I actually push that in, it will show it there, but I don't think actually it goes to as accurate as that. Yeah, it actually goes, it puts it in, but it actually only to 3 decimal places after the point on megahertz. So, but nevertheless, it's still very accurate, and that's still fair. 3 decimal points is pretty accurate for a built-in function generator. Obviously, it's a single output, as on my Keysight 3000 is a single. You don't normally get dual output frequency generators until you start talking about very expensive scopes, and to be honest with you, then anyway you'd probably be using a separate frequency generator with an amplifier probably, but anyway, that's the frequency generator. We'll just have a look, because this video has become quite long now and I was going to keep it relatively short. We'll just have a little look at, I'll reset this up and then we'll have a little look at the different acquisition modes and the quality actually of the output math signal, which is very impressive. So we'll put that back to 50. We've now got a 50 Hertz sine wave, and I'll just set up so that we'll have a look at the acquisition modes as well now. Okay, I've come in a little closer to look at the quality of the waveform now, of the maths waveform. Most of this demonstration I've been running on high res, so if I go to, say, sample, you'll see that the waveform is a little noisier, which this is exactly the same. I've tried this on my Keysight and my Rigol, it's almost unusable. You get a very blocky waveform, but that's because it's not doing any averaging now, so consequently you get more noise on that, and even the waveforms themselves are a little bit noisier. And I am just using a breadboard with stray capacitance, and obviously it's probably picking up some noise from the lighting in my lab, etc. I've also got peak detect, which will make the waveform wider because it's picking up the peaks of the signals. I've got high res, which I've been running the whole demonstration on, which gives you a beautifully clean signal. And in actual fact, the math signal on this is much cleaner than the math signal on my Keysight. It looks more like a 10-bit math signal, which is probably coming in because of the 10-bit ADC on the normal analog channels. If I then go to average, I'm getting almost as good as my high res, and sometimes average is better. At higher frequencies I'm finding averages gives you a nicer quality signal, which I'll demonstrate in a minute. You've then got envelope mode, which is like I've shown before, it gives you an envelope of the signal with persistence, and you've also got envelope with peak detect, which will be thicker and higher because we've got persistence on and we're picking up the peaks of the signal. So we're now getting quite a wide signal. If I do that, you can see how that looks on the signal. If I now go back to average, I'm running that at 8 averages, which is all I need to do actually, and 8 averages works pretty quickly. If you look at after the 8, you'll see as I alter the time base it has to redo my averaging, and it takes a little second or about 2 seconds for the signal to get clean. So if you look at that signal, as I do that you get more noise and then it cleans it up by averaging, and the 8 will have an exclamation mark next to it that takes a couple of seconds to disappear, and I can't find it in the manual, but I assume obviously that exclamation mark means that it's in the process of averaging and hasn't actually completed the average yet. So if I do that, it's going to take a few seconds to average out all the signals, and it's done probably because there's more information to average out the whole screen. If I come in to the signal like that and I alter it like that, it's about 1.5 to 2 seconds to run an average on it. I think the high res uses boxcar averaging, and for whatever reason that is much quicker. It just has the signal clean all the time. It's just that at higher frequencies it doesn't seem to work. So if I go into the generator and I choose, say, let's put on say 2 megahertz for instance. Right, alter my time base to get this signal back in again. Now we're still, now even in high res now, ignore the shape of the wave because the diodes aren't really suitable for a 2 meg signal. They're not fast enough reacting rectifier diodes. But if I now go to average, I think we'll find, yeah, which it does, and I found this on my Keysight as well, the averaging gives you a better signal than the high resolution. So for some reason, the other one's obviously peak detector going to be very noisy and very thick. That's obvious. Envelope is going to be the same, and envelope plus peak detector will be very thick and noisy. But if I go to high res, we're not getting that same detail that we were before. It's obviously something to do with the way that the averaging works and the higher frequency of the signal. But if I actually go to average, then it's pretty clean, and I can get that even cleaner because I'm only running 8 averages. If I go into my average mode, click on that, and let's say we put in 24 averages, say, which takes a little bit longer in processing, but the signal gets even thinner and it's back to almost what it looked like at a lower frequency. It just takes longer obviously now. When I click that, if I move that, you can see 1 and 2. 1 and 2. It's taking about 2 seconds I think to average out that, and you can see all the noise and all the individual bits on the signal, and then you'll see it average it out. But that's pretty clean. Whereas if I now go back to high res, it's not as good. So high res seems to work at lower frequencies, but it doesn't seem to work for some reason at higher frequencies, and I'm not sure why, but I managed to get round that just purely by using average. It takes a couple of seconds, but basically then we've got a pretty clean signal again. As soon as it averages it out, there's not a lot wrong with that. That's a pretty clean signal. You can see that persistence is on, by the way, which is what I was saying before about this signal working the same as my analog. So you can see that the persistence is staying on because I've probably got persistence switched on, I think, on this. I'm sure I have. But let's take this frequency back down again to, say, 1 kilohertz. Let's alter the time base. And at 1 kilohertz, let's see what the averaging is still working beautifully at 1 kilohertz, but let's see what happens if I go on to high res. So at 1 kilohertz, the high res is still working very nicely, and that's a beautifully clean signal, and it's actually a far cleaner maths signal than I'm getting on my Rigol, which is almost unusable, and substantially cleaner still than on my Keysight, which just appears very blocky. The math signal is good when you average it or use high res depending upon what frequency you're at, but this just is cleaner. So I really hope that they give us some more maths functions to match the 3000 series, because the only criticism really of this scope my main criticism, because the more I use this scope the more I like it. My only real main criticism is that I do use maths functions and integration, area under the curve, etc., and of course this just doesn't have it, so I have to then reach for my key sight. This only has at the moment addition, subtraction, multiplication, division, and I really love to see more. The key sight will also do, my one will also do maths on maths, so you've got two maths channels, which although you can't display both at the same time, which is quite strange really, if you set up maths channel 1 to do something, maybe to say power, so you might times volts by amps if you've got a current clamp on, you can then set up channel 2 of your maths channel to integrate that, so you can get the area under the curve for say a power reading, although you can't show both at the screen at the same time. It just won't let you. I think on the 6000 series key sights you can, but obviously you're talking about a lot more expensive scope. I appreciate these aren't cheap scopes in their own right, but you know, when you're talking about two maths channels and all the functions, you're talking about scopes that go into many thousands of pounds, and not just, you know, not the 3,000, 4,000, 5,000 pounds, but probably into the 15, 20, and fine for larger companies, but not for smaller companies or the individual. They're obviously a little bit out of most people's range of their pocket. But anyway, that was just a quick look, which wasn't quick actually, at the basically the maths functions, because I was using them recently. And my next video I will actually go back and show the micro professor board that I bought at Christmas time and some of the signals coming out of that. And I'm also going to see if I can find some information out directly from a contact. I've got a contact at Rohde Schwarz. I'd like to find out whether the firmware update is coming and when it might be, because I'm rather looking forward to the firmware update. But the more and more I use this scope, the more and more I like it, and I'm reaching a lot of the time now, as I've said before, for this scope, the screen is just bigger, particularly for instance with this, when I was looking at basically 3 channels plus a maths channel, it's just so much more real estate on the screen. The maths function is just the limiting factor, that I wish they had a bit more maths functions, and I hope they do write that into the firmware. But anyway, I hope you've enjoyed that video, and I will be back hopefully within the next week or two with a follow-up video. Bye for now.